In this video, we're going to be constructing a 163 amp hour 12.8 volt battery with a 250 amp Daly BMS. Step number one is obviously to wear safety glasses when working with any batteries. It's difficult to see in the video, but this side's all positive, this side is all negative. As we want to put 4 cells in series, we'll need to switch these over. Okay, now we can start putting our links on. So we have the first cell negative, so that'll be the battery negative. Then the positive will go to the negative of the following cell, and again the positive to the negative of the following cell, so on and so forth. This is our Daly BMS balance measurement lead. So we'll start with the positive, so the furthest away from the black cable. This will go on the positive terminal of the battery. Then the following lead will go on the following cell. Now it's very easy to get the leads wrong, particularly when you're using a battery made up of, for example, a 4S, 4P, and even more so when you're using up to a 16S. So that's why never trust yourself when putting on these leads, because if you plug it in and they're incorrect, it will destroy the Daly, or any BMS for that matter. So first thing we do after assembly is test with a multimeter to check the correct polarity. So there's my black lead on the pin on the black cable, and then following the adjacent red pin, and you can see that we get roughly 3.2 volts. The next one 6.5, 9.8 and 13. So that indicates that the voltage is moving up linearly. If we if we found we got 3.3, then 9.6, then 6.6, and we plug that into the Daly, it would destroy the Daly. So this is a good time to check. If you get anything wrong, you can swap it over and then keep going. Now that's out of the way, we will connect our BMS. So a common question is if the BMS goes on the positive or negative. The BMS only disconnects the negative side of the battery. Neither of these cables should be touching the positive or any other voltage on your battery. If you do, you'll get a short circuit. So now, if there is any faults, the BMS will cut the supply of the negative of the battery to the rest of the load. This thermistor plugs into NTC, which stands for negative temperature coefficient. And the Bluetooth module plugs into the UART port of the BMS. And then we plug in the balance / measurement pins. And now you have your battery negative and your battery positive. So now the battery BMS is connected, we need to wake it up. So you need 0.7 volts above the battery voltage in order to wake up the BMS, because it starts in a safe mode. The safe mode basically means that it's had some issues such as the cells being under voltage. Obviously if it's not plugged in, the cells are going to be under voltage according to the BMS. So you'll connect your charger to the P negative, which is your battery negative. So all loads and all charges will be connected here. This is the battery positive, all loads and all charges will be connected here. We have our Victron mains charger here in order to wake it up. You don't have to use a Victron mains charger, you can use any old charger as long as they're suitable to put out a voltage in order to wake up a BMS that can put up 0.7 volts above the battery voltage. Some of them, if they don't sense a voltage from your battery because the BMS is off, they might not put out a charge at all, and then therefore it won't wake it up. But the Victron units are really good for that. So in our case, I have it set to power supply mode of 14.6, well above the 13 volts in the battery, and well above the 13.7 volts required, so that will certainly wake it up. So now I've done that, I can start to see the Daly. So it does its thinking when it first wakes up, and so now we can see the data. So the state of charge won't read accurately when it's first woken up. You can see the current the Victron is putting in. The charge MOSFET is green, which means it's enabling charge to go into the battery. Discharge MOSFET is green, which means it's allowing you to pull load from the battery. It'll start to balance when your voltage is above 0.05 differential volts between the cell to cell. Some things to note about the Daly BMS app. When you go to your parameter settings, some of the settings are quite far from where you would probably want them. For example, the cell low voltage protect is set to 2.2 currently. Most cell manufacturers will recommend not going below 2.5 volts minimum, and therefore if you go below that you should turn off your discharge MOSFET. I don't recommend changing these set points in the app itself though. I recommend changing them in the PC software and referencing your cell manufacturer's data sheet. That's because in the app you can see the trip points, but you can't see the reset points. So normally if you change a trip point, you would correspondingly change the reset point. The other note is that the parameters, these switches don't work on the 3 and 4S units, but they will work on the 5 to 32S Daly units.